Alright, this is my attempt at explaining the circular buffer. This program is based on UNC Charlotte's YouTube video on a circular buffer. It's the exact same program. It's my amateur take on it. I got the program here in Atmel Studio. I can ignore these first two lines as part of my header file. And first line is define the queue size. So this will define the size of our buffer. In this case it's 8. And then next lines here we've declared a structure. And remember, a structure is a container. It contains different types of data types. In this case we have an array, an unsigned character array called data, and the size of the array is the queue size, which is 8. And we have 3 integers, one each for the head, the tail, and for the size. And then the name of the structure is QT, and then I have a pointer, my buffer pointer pointing at the structure. And then we have a series of prototypes here. First one's to initialize the structure with the values that we want. In this case, initially we're going to initialize everything to 0. So we'll have all the entire array, each indexer in the array will be set to 0. The head will be 0, tail, and the size will all be equal to 0 through this initializing function. And then we have a function for checking if the buffer is empty, and then one for full, and then a function for putting data into the buffer one at a time, the enqueue function, and the dequeue function for taking data out of the buffer. So initializing the buffer here, this method, you can see here we have a nice little for loop that will go through the entire array, and there's 1 byte in each one of these indexers of the array. So this for loop will read the size of queue size, which is 8, and then iterate through setting each value in the array to 0. And then we explicitly set the head, the tail, and the size to 0. Notice that because we're using a pointer, we'll be using use the arrow symbol. If it wasn't a pointer pointing to the structure, then it'd be like the dot operator to change the values inside the structure. But because it's a pointer, my buffer is a pointer, then we use the arrows to change the values inside the structure. And the empty function's very simple. It compares the size, or the size here, compares it. If it's equivalent to 0, then it'll return the size. And if the buffer is full, it'll compare the size to our queue size. So obviously when the size reaches 8, the buffer is going to be full, and then it'll return. Now the enqueue function, well, basically how I have it set up here, here's the indexer for the array, and then we have zeros all set inside the array. Size is 0, and we have our head and tail set to 0 for the 0 indexer. So this is what it's going to look like after we run that initialization function up here. And so say we want to put in our first bit of data. We've received this, for example, what I'm using it for is to receive data over the UART into an interrupt ISR routine, and so every time I get a byte coming over the line, I want to insert that byte into the circular buffer. So I'll call the enqueue function every time the interrupt receives a data byte. And this is the function that it'll call. First it'll check and see if it'll call the queue full function, check to see if the buffer is full. If it's not full, then it'll proceed to let's say we want to put the letter A into our enqueue. So we call the queue enqueue function. And then we have two parameters. We have our pointer to our structure, which was my buff. And then the second parameter is an unsigned character. In this case, what did I say, letter A. So we've just called the enqueue function. So what happens? Well, it checks to see if the buffer is full. First of all, from this function, obviously our size is equal to 0. So size is not equivalent to queue size. So it's not full. The buffer's not full. If the buffer's not full, then it'll take our pointer structure. It'll take and it'll assign the in the data array. It'll assign the value A. So where's the tail pointing at this point? Well, we've initialized the tail to point to the 0 indexer of the array. So that's what it's pointing to right now. And we set it equal to D, and the D value is the letter A. And so now it's going to put the letter A right here in the first indexer. Alright, so we have the letter A in the first one, and then it post increments the tail by 1. So the tail is now equal to 1. Indexer 1. And then this modulus operation, from what I can understand, is basically this line is what is going to reset the tail when it reaches the end of the buffer. When the tail reaches queue size 8 equals 8, and there'll be no remainder. So as far as what I can understand is that if there's a remainder, then it's the Boolean is 1 for the modulus operation, and then if there's no remainder, then it's 0. So basically, at this point, we've got the tail equal to 1 divided by 8, leaves a remainder. So it's equal to the modulus is equal to 1. So the tail stays at 1. And then our size is incremented to 1. And then it returns 1 if the operation was successful. Otherwise it returns 0. Alright, so let's stick the number 2 in our array, our circular buffer. So we'll call the enqueue again. with 2. So we'll go through the same thing. Is it full? Is the buffer full? Well, is the size equal to Q size? We know Q size is 8 and our size is now 1, so it is not equivalent. So it's not full. Proceeds to the next line. Alright, so our tail at this point is to our 1 indexer in here. And our data is 2, so it's going to stick a 2 here. Just stick the number 2 here. Then it's going to post increment the tail to 2. So now it's up to the 2 indexer. And do the modulus, which is now I guess 2 divided by 8. So we still have a remainder. So it'll stay 2. And then increment our size. Size was 1, so now size goes up to 2. And that is successful, so it returns 1, signaling that it was successful. Alright, so let's continue. Let's put in the letter Z. So is it full? Is the buffer full? Well, is the size equal to Q size? 2 is not equal to 8, so the buffer is not full. Continues to the next line. Our data, our tail is sitting here at our second indexer with a 0 inside of it. But with this Q arrow, that will change that to Z now. So this goes away. Placed by Z. Because then obviously in this line we said it equal to D, and D is Z in this case. Do the modulus again. We incremented the tail. We have to increment the tail, post increment it. So the tail is 3. 3 divided by 8. We'll use the remainder. So tail stays 3. And the size increments. From 2 to 3. And we'll continue in part 2.